We are trying to find the zeros of this polynomial. We can't, there's nothing to factor out of the whole thing. There's too many terms. I can't just factor by grouping. This is not the sum or difference of two cubes. So basically we had to come up with a new skill. So we use the rational root theorem to tell us if there are any rational roots. They will be found in the list of all the factors of your constant divided by the factors of your leading coefficient. So that's what we did here. We made that big long list, and I know it looks like a lot of numbers, but before you had an infinite number of numbers. Now I'm down to a handful. So now I'm going through this list and I'm trying to find one that works. So how do you do that? You use synthetic substitution. So you just keep plugging in the numbers until you get a remainder of 0. Yeah?
Is there any way to tell if you're getting closer to the...
No. You just know it's going to be in that list, so... Yeah, you just keep going till you get a remainder of 0. So, we did. We plugged in 1 and -1. They didn't work. Then we plugged in 2, and it worked. Okay? I plugged in 2. I got 0 as a remainder. So, remember what that means, ladies and gentlemen. That means that x minus 2 divides evenly into the original polynomial. So, in other words, if it divides evenly into it, it's a factor. And then remember, all these numbers are the coefficients of what's left. So I've taken that big quartic polynomial and I've factored it into these two. So if I multiply these two back together, I get right back here. So I have one of my zeros. I know there's going to be 4 altogether. So I need to keep looking. So now I have this. Here is a 4-term polynomial, and I basically need to do the same thing. I'm trying to find the zeros. You can try now and factor by grouping. You might get lucky, right? If I split this in half, would I get the same thing if I tried factoring by grouping? Will that work on this one? You can tell pretty quickly, right? If I split this in half and I pulled out a 7x squared, I'd have x plus 1. I'm not going to get that over here. So I'm not going to be able to factor this by factoring by grouping. Oh well, too bad, so sad. So basically what I need to do is I need to keep doing the synthetic substitution to find a second 0. So, but I don't have to go back to the original numbers. I can just do the numbers that are right here. 1, 7, 16, 12. And here's the other good thing. 1 and -1 didn't work in the original, so they're never going to work. I never have to try them again. I do want to try 2 again, though, because what if it's a double root? So I'm going to try 2 again, and I'm just going to keep going down my list until I find another 0. But then I'll be almost done, okay? So I'm going to try 2 just to see if it's a double root or not. And again, as soon as you realize it's not going to work, stop. Oh yeah, it's not going to work. I already know it's not going to work because look at this. Here's another neat little trick. See how all of these are positive numbers? So if I plug in a positive number, am I ever going to get a -12 right there? No. So that actually eliminates half my numbers right now. I know it has to be a negative number that goes in here, right? Otherwise it's never going to, if all of these are positives, that means that that's got to be a negative number. So let's try -2. -2, that would be a 5. That would be a -10. That would be a 6. Hey, look at that. I just found my second 0. -2 is also a 0. So now that means my crazy polynomial, right? I've now factored it again. I split this one up. So I have x minus 2 from way back when. And now this I just split into x plus 2. And then these are my coefficients of what's left. X squared, 5x, 6. Do you see what I've done? Does everybody see? Is that okay? So that x minus 2 came from the very first 2 that I found that worked. So that means the factor it came from was x minus 2. I just plugged in a -2, so the factor that came from was x plus 2. And then these are the coefficients of what's left. The remainder, constant, x to the first, x squared. But now, guys, This is a quadratic, and I can solve quadratics all day long. I don't have to do synthetic substitution anymore. Now I can just solve this quadratic like I normally would. Square rooting, factoring, completing the square, quad formula. Are there factors of 6 that add to be 5? Yeah. 2 and 3, right? So that means my factors are x plus 2, x plus 3. So now I can just set each factor equal to 0, and I have my 4 answers. What are they? I get 2, and then check this out. Don't I get negative 2 twice? Right? So I'm going to write negative 2 with multiplicity 2, and then negative 3. Ta-da! Look at you go! You just factored this crazy polynomial and found its 4 zeros, given no information. Ready to try another one? Yeah, Liberty.
If there's
Okay. All right. So